In military mathematics, nothing is more ruthless than distance and geography. When Operation Epic Fury erupted in February 2026 to counter Iran's naval and air defense networks, the Pentagon faced an unalterable equation. The global economy and military lifelines in the Middle East depend on three vital maritime choke points: the Strait of Hormuz to the east, the Bab el-Mandeb Strait, connecting to the Red Sea to the south, and the Suez Canal to the west. To lock down Iran and its proxy forces, the U.S. Navy needed 3 aircraft carriers holding these 3 doors, but America only had 2 available. The USS Abraham Lincoln was ordered to hold the Strait of Hormuz, facing the Iranian coast directly. The remaining colossal responsibility, shouldering both the Mediterranean flank and the Red Sea choke point to counter Houthi rebels, was placed on the newest, most expensive aircraft carrier in human history, the USS Gerald R. Ford, hull number CVN-78. The Americans believed that the Ford-class's cutting-edge technology could make up for the shortfall in numbers. But they forgot a fundamental law of physics. Machines can be designed for perfection, but they are not designed to stay awake indefinitely. The USS Gerald R. Ford is no ordinary aircraft carrier. It is a massive, floating computer. The core difference between the Ford and previous generations is the Electromagnetic Aircraft Launch System, or EMALS. Instead of using crude, mechanical steam thrust, EMALS uses digitally calibrated linear induction motors to launch fighter jets. Thanks to this, the Ford can generate a staggering surge capacity, 270 sorties a day, far exceeding any historical record. It is smoother, more precise, and more devastating. But that digital perfection exacts an invisible toll. EMALS is a deeply intertwined network of interdependent systems: power conversion electronics, energy storage modules, distribution networks, and software feedback loops. Everything is tightly integrated. By the time Operation Epic Fury broke out, the Ford had been at sea for 9 months. 283 continuous days of transiting from the Mediterranean through the Caribbean and looping back to the Red Sea without a single day of rest, without a single scheduled depot-level maintenance reset. The accumulated fatigue on its 5,000 sailors and millions of microchips had pushed past the operational envelope its engineers had originally calculated. It was like a supreme smartwatch, functioning flawlessly right up until the battery completely drained. The 12th of March, 2026. Week 3 of Operation Epic Fury. The enemy didn't sink the USS Ford with ballistic missiles or torpedoes. What brought this $13 billion machine to its knees originated from within: a fire in the aft laundry compartment. An industrial dryer, overworked by months of continuous use, ignited. The human toll: toxic smoke from synthetic fabrics and detergents surged through the forced air ventilation system. Despite the damage control teams extinguishing the flames within minutes, the thick smoke resulted in 4 fatalities due to asphyxiation and 32 sailors suffering from severe burns or respiratory trauma. The resulting chaos and the emergency evacuation of adjacent berthing areas paralyzed the flight deck's operational rhythm. The systemic fallout: the real disaster wasn't the fire itself, but the recovery efforts. Water and firefighting foam seeped into structural gaps, compromising sensitive fiber optic cables and power distribution modules. This triggered a cascading failure across the ship's exhausted digital architecture. The EMALS control software threw a fatal error. The electromagnetic catapults went dark. Despite its intact armor and weaponry, an aircraft carrier that cannot launch planes is merely a 100,000 ton strip of useless steel. The Ford was forced to withdraw to a shipyard in Croatia for an emergency overhaul. The Ford's withdrawal created a strategic nightmare. The Bab el-Mandeb Strait was suddenly left uncovered. In Washington, the news triggered a political firestorm. Lawmakers at the Pentagon demanded answers. How could a laundry room fire neutralize our most powerful asset? The media labeled it the Achilles heel of the digital age. The consequences were immediate. Sensing the absence of American airborne deterrence, Houthi rebels in Yemen unleashed a barrage of ballistic missiles and suicide drones aimed at international shipping lanes. 2 large oil tankers were struck and set ablaze in the Red Sea. The southern flank of Operation Epic Fury was peeled wide open. America's entire deterrence posture was under threat. They didn't need a perfect machine, they needed a machine that worked. The U.S. Navy's answer didn't come from the future. It came from the past. The USS George H.W. Bush CVN-77, the last Nimitz-class carrier ever built, representing technology born in 1955. The Bush lacks electromagnetic catapults and complex digital power grids. Instead, it hurls FA-18 fighters into the sky using brutal, loud, and heavy steam catapults. It can only sustain 120 sorties a day, less than half of the Ford's theoretical capacity. However, the Bush possessed what the Ford had lost: mechanical endurance. When a steam pipe leaks, a mechanic with a wrench and a hammer can fix it on the spot. It isn't brought down by a software glitch or a digital domino effect. The moment the order was given, the USS Bush surged across the Atlantic to plug the hole, proving that rugged simplicity often defeats fragile complexity in the heat of battle. The replacement of the Ford by the Bush in the epicenter of a global crisis reshaped military philosophy forever. The Ford class represents the technology of tomorrow, sophisticated and powerful. But in the chaotic, dirty, and prolonged reality of actual warfare, highly interdependent systems can become a fatal liability. The greatest lesson from Operation Epic Fury isn't about firepower, it's about endurance. In the most pragmatic military sense, the best war machine isn't the one with the perfect specs on paper. The best war machine is the one still standing on the battlefield when everything else has failed. Availability always defeats optimality, when the optimal is no longer available.